This is the Chem 1 lecture of acid nomenclature. This is going to be our third naming system. So there is a specific naming system for covalent compounds where we got to use our prefixes like mono, di, tri. There's a separate naming system for ionic bonds where we swapped and dropped our charges and had to use Roman numerals for multivalent metals. And then there is a different system for acids. So at the very beginning of this unit, we mentioned that acids always have a hydrogen to begin their formula with. So when an acid dissociates or breaks up in water, you see hydrogen ions and then an anion. So all acids are going to start with a hydrogen in their formula. And so if everyone starts with an H, we're not really going to focus on the H, we're going to focus on what's attached to the H. And that's going to be the negative part called the anion. So we will name acids based on their anion. So there's basically three things that can be attached to the hydrogen. There can be a single element, so that would end in "ide" if it's in a bond. And you could also have a group attached to the hydrogen that could have the ending "ite" or "ate." And so there's three different namings that we'll do. So if you have H and one other element, we're going to say hydro, the stem of the element, ic acid. So for example, this would be hydrochloric acid. So if you have HBr, hydrobromic acid. When you have a polyatomic, or I'll call them groups, you drop the hydro and you focus on the name of the group. So in this case, because NO2 is called nitrite, ite is going to switch to us acid. So this becomes nitrous acid. And then if your group, so we drop hydro when there's a polyatomic, when there's a group. SO4, the name is sulfate. 8 will change to ic acid. So that will become, directly it would be sulfic acid, but it's technically sulfuric acid. If you wrote sulfic acid, we would not count off, but technically it is sulfuric acid. So here's a diagram to kind of look at what we just broke down. So all acids start with an H, and then you have to look at what's attached. If it's just one other element, I call it there's no group, then you're going to do hydroic acid. That's how you're going to name it. If there is a group, so more than 3 elements total, you're going to drop the hydro. 8 goes to ic, ite goes to us. And we have a cute little saying, if you can remember it, ic, I ate a humongous bite. So ic and 8 go together, us and ite go together. So that will hopefully remember it. Sometimes I do, if you ate it, it tastes ick. And then y'all sometimes get senioritis. So just making sure those pairs stay together. And then there is one exception to this kind of flow chart. So HCN, if we're going with 2 elements, 3 elements, this would look like a group and we would drop hydro. However, cyanide ends in IDE, and so we're going to treat it like the IDE where we're going to say hydrocyanic acid. So it's a good one to know. Exceptions have a way of popping back up. So instead of dropping hydro, we're going to call it hydrocyanic acid. So let's work on naming acids. So I see the H. All of these are acids beginning with an H. And so here I see a polyatomic, PO3. So I'm not going to say hydro. I'm going to go look up the name of PO3, which is phosphite, ITE, and we know ite struggling on that. Ite goes to us. So this would be phosphorus acid. Technically, it's called phosphorus acid. If you miss a couple of words, we're not going to count off as long as we want to see you using the rules correctly. Okay, HIO4. So once again, I see a group, IO4, so I'm not going to say hydro. I'm going to look up IO4, and that's per iodate. What do we do when things end with ate? If you ate it, it tastes ick. And so we're going to take out the ate and put in ick. And so it's technically per iodic acid, but if people were reading it quickly, they might see periodic acid. Okay, we have H3P. Notice that there's not a polyatomic, there's not a group, and so we are going to say hydro. That's phosphorus. We're going to change it to phosphoric, hydrophosphoric acid. Okay, let's do H2SiO3. I see a polyatomic, so I'm going to focus on that name, not say hydro. SiO3 is silicate. So I use the back of the periodic table. Ends in 8. We take out 8 and put in ick. And this becomes salicylic acid. H2S, it's just a binary acid, 2 elements total. So we're going to say hydrosulfuric acid. And then last one for naming, HBRO. BRO is a polyatomic on the back. BRO is hypobromite. And often I see you guys get a little wigged out because it says hypo. That's different than hydro. So we're not saying hydro, but hypo is part of this name. So we take out ITE and replace it with OUS. So it becomes hypobromous acid. So now we're going to work backwards. When I give you carbonic acid, we're going to make a formula. So you have to really pay attention to the endings, not necessarily acid, but the ics and the hydros, and just, I guess, pay attention to everything. We know that if they're ending in acid, all acids have a hydrogen in there. So no matter what, all of these have to have a hydrogen. Now notice I'm writing these as ions. So similar to ionic compounds, you're going to have charges that you swap and drop. The only difference here is that you always have a hydrogen as one of your ions, as the positive, the cation. So now carbonic acid. I notice that there's not hydro, so this has to be a group, a polyatomic. We had 8 went to ick, right? You ate it, it tastes ick. And ite to us acid. So now I'm going to have to work this backwards. If we're seeing ick acid, this must have come from carbonate. If you look on the back of your periodic table, carbonate is CO3 with a -2 charge. So my charges are not currently balanced to 0. I'm going to need 2 hydrogens and 1 carbonate. So we don't have to write the 1. So this would be H2CO3, carbonic acid. Sulfurous acid, also no hydro, so this is looking like a polyatomic. Us acid came from sulfite. So use your back of your periodic table, SO3 with a -2 charge. Swap and drop down. Or another way to look at it, you need 2 hydrogen ions to balance your sulfite ion. Hydroiodic acid, first time seeing hydro, this indicates there is H and there's one other element. In the word iodic, do y'all see iodine? And iodine, based on where it is in the periodic table, is a halogen. They want to gain 1 electron, so they take on a -1 charge. Yay, our charges balance. HI, hi, is the formula. Hydrobromic acid, so we see hydro again. So that means there's only going to be one other element besides hydrogen. So out of hydrobromic acid, I see the element bromine, also a halogen, -1. So that's HBr. Arsenic acid, okay, so no hydro, so this is a group. arsenic acid rooted from 8. This is arsenate. So you have to go look around and you find ASO4, and the whole group has a -3 charge. So that 3 is I'm going to need 3 hydrogen ions to balance out 1 arsenate ion. And then last one, nitrous acid. So we know acids have to have an H. Nitrous, this is coming from a group because I don't see hydro. Us came from ite. So this is nitrite, which is NO2 -1. Our charges are already balanced. So you just have 1 of each ion, a 1-to-1 ratio. Okay, and that completes the acid nomenclature tutorial. Thanks for watching.